Arithmetic. Sorry, it's a long day. All right, third grade, we're going to do arithmetic. You're not arithmetic. This is arithmetic. Yeah. It's time for Thanksgiving break, don't you think? So we're just going to do some quick arithmetic and then we'll get you to Christmas. Oh my goodness. Thanksgiving break as soon as we can. And then on to Christmas break. Because obviously I'm ready for both. Sorry about that. Anyway, not even going to bother editing that out because reality is this. This is reality. Okay. Hey, third grade, it's arithmetic time before we get ready to go on Thanksgiving break. I hope you're ready for it because I certainly am. So we're going to start off with doing some column addition. So I'm going to bring you in closer so we can be prepared. There you go. You can see that really well now. All right. So I want to hear you saying, like we do in class all the time, say our number, then what you've added, then what you've added as we go down. Try to beat me. I don't know if you can. We'll see. 4, 11, 16, 22. Did you stay with me? Or did you beat me? 2, 2, 4, 7, 15. If you're not going as fast as this, that's what I want you to strive for. I want you to strive to be able to keep up with me that quickly. 1, 10, 15, 17, 21. 2, 10, 17, 25, 31. Sorry. And 3, 12, 14, 15, 23. Did you get that? All right. Oh, my marker's being weird. Now I know, no naked numbers. So put your comma, 1, 2, 3 spaces from the right. We put our comma. What is our answer? 231,152. But we've got to check it going back up. Maybe Miss Monroe made a mistake. We'll see. Let's check it out. 6, 11, 18, 22. 2, 10, 13, 15, 15. 1, 5, 7, 12, 21. Are you staying with me? Some of you are not telling the truth. 2, 8, 16, 23, 31. Did you get it? 3, 11, 14, 12, 14, 23. I know. I'm not going to leave it naked. All right. Look, let's see. 231,152. Same both ways. So we did it correctly. So we're done. Good job. I hope that you did stay with me as much as possible. Okay, since this is going to be just a quicker at-home lesson, I'm going to make you do some tables with me. So let's do our 6 multiplication table, head, shoulders, knees, toes. 0 times 6 equals 0. 1 times 6 equals 6. 2 times 6 equals 12. 3 times 6 equals 18. 4 times 6 equals 24. 5 times 6 equals 30. 6 times 6 equals 36. 7 times 6 equals 42. 8 times 6 equals 48. 9 times 6 equals 54. 10 times 6 equals 60. 11 times 6 equals 66. 12 times 6 equals 72. Good. All right, let's do our 5 division table. So every time you say equals in the answer, squat it down. 0 divided by 5 equals 0. 5 divided by 5 equals 1. 10 divided by 5 equals 2. 15 divided by 5 equals 3. 20 divided by 5 equals 4. 25 divided by 5 equals 5. 30 divided by 5 equals 6. 35 divided by 5 equals 7. 40 divided by 5 equals 8. 45 divided by 5 equals 9. 50 divided by 5 equals 10. 55 divided by 5 equals 11. 60 divided by 5 equals 12. Good. All right, and then we're going to do our 4 division table. 0 divided by 4 equals 0. 4 divided by 4 equals 1. 8 divided by 4 equals 2. 12 divided by 4 equals 3. 16 divided by 4 equals 4. 20 divided by 4 equals 5. 24 divided by 4 equals 6. 30 divided by 4, no, 28 divided by 4 equals 7. 32 divided by 4 equals 8. 36 divided by 4 equals 9. 40 divided by 4 equals 10. 44 divided by 4 equals 11. 48 divided by 4 equals 12. Hopefully you did those. Do it with me. Make sure, say them out loud nicely so you can hear those. All right, so our new concept for today, hold on one second. Let me make sure I have one other thing that I want to make sure I have. Okay, so our new concept for today is learning to be a good detective again, but we're going to be looking at this here. And you're looking and you're like, Miss Monroe, isn't that for language class? Because it's got declarative sentences, interrogative sentences, right? No, this is something that's very important. Some of you think, oh man, my parents are so lucky. Now I don't ever see them doing arithmetic pages. They're not sitting there going, 54 divided by 9 equals 6. 63 divided by 7 equals 9. Like, they're not doing this stuff that I'm doing. They don't have to worry about math anymore. Lucky them. Well, that's not really true, because your parents do have arithmetic problems that they have to think through every day. If your mom wants to buy 3 pounds of bananas and each pound it costs 79 cents, she's probably going to estimate, it's about 80 cents. 80 times 3, okay, that's going to be $2.40. Do I want to spend $2.40 on bananas, or do I want to see if I can find a better deal somewhere else? She's going to estimate to figure out that problem and see what the cost could be. That's a story problem. Then maybe she goes to another store and she finds a different price. Maybe they're at 69 cents a pound, so she rounds that. And then she decides, now 69 would be 70 cents a pound, that'd be $2.10. Well, let's see how much difference. Oh, that'd be about 30 cents different. Will that make a difference in my, and she's doing that story problem. Maybe dad is, getting ready to help fix something in the house or put something up in the house because mom's like, I really want this picture hung on the wall. And she's like, but it needs to look just right. So dad's going to measure. He's going to use a measuring tape and measure the length. And then he's going to look and see, depending on how long it is, okay, well, this wall is 20 inches wide, so I need to make sure that the picture is somewhere in the 10-inch range, because that's halfway between 0 and 20 is 10. So let me try to get that figured out and see if I can make it just the right size in the right spot all the time. Oh, this gas is this much here, but it's this much over here. Let's see how much difference that is. You don't think about it, but every day, mom makes cookies. She needs to know, is it going to be enough for all of, my kids' class? Is it going to be enough? They've got 14 kids in the class. This recipe makes a dozen cookies. Is that going to be enough? I asked you a question. Okay, yeah. And this isn't just to listen. This is to participate too. Is that going to be enough if she makes a dozen cookies? No. What's going to be missing? Yeah, 2 cookies would be missing. So she's got to make maybe 2 dozen instead of just making 1 dozen. Or she's got to figure out a way that she can maybe only make 2 more cookies out of the dozen it's supposed to make. But she's got to figure that out. And then if she does make 2 dozen, then she has to double everything in the recipe. Instead of 1 cup of milk, oh, I got to use 2 cups of milk. Oh, instead of 1 cup of flour, I need to use 2 cups of flour. Instead of half a cup of sugar, I need to use a whole cup of sugar instead of so they're doing math problems all the time in story problem form. So in order to find an answer to a story problem, we have to find the facts. So there was a show that came on years ago. It was even before my time, so I don't really know it that well, but I do know the phrase where it says, just the facts, ma'am, just the facts. So when a detective is trying to solve a problem, he just wants to know the facts. Don't give him, this is what I did when I woke up, and this is what I did when I was going, and then I went to the store, and then this. No, I don't need to know all the ins and outs. I just need to know what happened when you think that this man stole your purse. Just the facts, okay? So we've got to look at our story problem and find just the facts. So let's look. The facts would be, interestingly enough, declarative sentences, right? Because declarative sentences are simply telling you something. So let's look for the facts. Ethan has 7 books in his desk. Jacob has 9 books. How many books do they have in all? So what are the facts that we need to see in this story problem? Well, good. So some of you figured it out. Ethan has 7 books. That's one fact that we need to know. Because if we don't know that, then we're not able to figure out the story problem. Jacob has 9 books. So those are the facts that we need to know. That Ethan has 7 books, Jacob has 9 books. Those are the facts. Then, after we find the facts in the problem, as you read the story problem and look for those facts, once you find them, find the question so that you will know how to figure out the answer. So what is the question that we have in this story problem? The question is, how many books do they have in all, right? Because that's the interrogative sentence, yes. So the first thing we did was find the facts, just the facts, right? 7 books and 9 books. Now we have to find the question that's going to help us answer our story problem. So we look at the question, which is how many books do they have in all? The next step is to decide how to use these facts. How am I going to use my 7 books and my 9 books? What process will I use to make those make sense? And when I find those facts that I'm looking for and trying to figure out what process I'm going to use, I need to look for clues. Any good detective is going to look for clues. Well, my clues would be something like these words right here. In all. So not only is it asking how many books do they have, but it's asking how many books do they have in all. And words like in all, or all together, or how many altogether, or both, or some, those help us to know that we need to add. So when we see words like in all, some, altogether, those are words that we know tell us that we should add. So because we have the facts, 7 books and 9 books, we have the question, how many books do they have in all? And we have the clue words in all. What are we going to do with our clues that we found in our facts? Well, we're going to take our 7 books plus our 9 books. And what are we going to do with them? We're going to add them together to find out how many books they had in all. And it would be 16. Once we find the answer, we have to label it. Now not just labeling right away, because this is the other key. One of the other steps that you need to use is, does my answer make sense? Because if it doesn't make sense, then you need to go back and look at your clues and look at your clue words again. Check the facts, check the clue words, and see, okay? Because if I said, okay, Ethan has 7 books, Jacob has 9 books, how many books do they have in all? 2 books. Wait. So if Ethan has 7 and Jacob has 9, we want to know how many they have in all. Does it make sense that they both all together have just 2 books? No, because even Ethan has more than that. Jacob by himself has more than that. We're putting both of their books together, so it's going to be 16 books. So you have to make sure that your answer makes sense. 2 wouldn't make sense, but 16 would. So if your answer doesn't make sense, then you go back, backtrack, look again, find the facts, ask the question, look for the clue words. If your answer does make sense, write it and then label it. In this problem, the answer is not 16 boys. It's not 16 desks. It's not 16 fingernails that you bit off. It's not 16, even worse, toenails. Whoa. It's not 16 teeth. What is it? It's 16 books. Okay, so we need to know how many books both boys had, and that's all that you're doing. So you have to follow steps. The first thing is to find the facts. Just the facts, ma'am. Just the facts. Second, find the question that it's asking. How many books do they have in all? Third, we need to find the clue. What's the clue word? When we see that clue word, we need to think, what process should I use? And then do that process. Figure out if your answer makes sense, and then label your answer. So you always need to put whatever the number is talking about next to it. Okay? So, very simple to do. Now, take out page 119. Page 119 in your arithmetic books. So, story problems. Look at what it says. Natalie has 5 pencils and Nathan has 3 pencils. How many pencils do they have in all? Find the facts, first step. Find the question. What's the question? How many pencils do they have in all? Decide how to use the facts to answer the question. So look for those clue words in the problem. Not all problems are going to have them, but this one does. And it's in all. And that means that we're going to add to get our total. Decide if your answer makes sense, and then write the answer, but also label it. Yes. So Natalie has 5 pencils. Nathan has 3 pencils. How many pencils do they have in all? 5 plus 3 equals 8 what? Pencils. You have to write pencils in there. So that's what you're doing for section 1. Read those story problems carefully. Look at the clue words. They have them in italics. There's fancy writing. So those help you to know what to do. But use the workspace. They're great. If I don't see you working in the workspace, then I'm not going to think that you are doing it correctly. So show me. You always show your work in arithmetic. So make sure to show me that. Okay. Then page 120, you've got your divide and check again. You know how to do those. And then solve and check these equations. So you've got n plus 4 equals 9 times 4, and then x minus 12 equals 55 divided by 5. So remember, do what you know. You know 9 times 4. Write that first, then bring the rest of the problem down. N plus 4 equals that answer to 9 times 4. Then get rid of my 4, so n is by itself. And then what I do to one side, I do to the other so I can find that hidden number. When I find that hidden number, plug it in to the top and see if both sides of my equation are equal. If you can't remember exactly, go back because I made these other videos that show you how to do those, okay? So look back at those other videos. And then don't forget with letter B, because it's a subtraction, how do we get rid of the 12? Do the opposite process. Then you've got fill in the blanks with greater than, less than, or equal to. So you've got your little Pac-Man section. Then write 100 more. It's not rounding. It's make it 100 more than the number that's there. So think carefully, especially for letter B. But you're writing 100 more. It's like if you added 100, okay? Then section 6, you're writing the products for those problems that you have there. All right, so really quickly before I go, because it's getting long. In 2017, the population of the United States was 326 million, okay? 326 million. Is that the actual population or is it a rounded number? How do you know? You think, most of you are saying you think it's rounded. How do you know? Because it's all zeros. Yes, you guys are so smart sometimes. No, all the time, most of the time, many times. No, you're very smart. Good job. Because it's all zeros. The actual population isn't going to be exactly 326 million, okay? It's going to be 326,895,622. It's going to be something like that. So when you think that through, if it's all zeros afterwards, that's a rounded number. Good job. If you got that, elbow bump, air high five, confetti. Good job, guys. All right. Good job. Work on that math page carefully. Do well and have a happy Thanksgiving because that's what's coming up, not Christmas. Okay, bye guys. See you in the next video.